So we're going to look at the different properties of a sine graph. So there's basically four different things we can do to a sine graph. We can change the amplitude, we can dilate from the y-axis, we can translate it left or right, or we can move it up and down. So let's see what each thing does. So this a value at the front is a dilation by a factor of a from the x-axis. So if we make a, let's say 2, this corresponds to our amplitude. So how high up does our sine function go from the x-axis? Okay, if we made it 3, it would go to from 0 to 3. If we made it negative, let's say it's -2, we can see that the height that it reaches is still 2. So when we talk about a dilation by factor of a from the x-axis, we always take that a value to be positive. Okay, and hopefully you can see that if it is negative, then that's just a reflection in the x-axis. So let's put that back to 1 because that's our most basic sine graph. All right, the next thing we're going to talk about is n. So that's this thing in here. Now this is a dilation by a factor of 1 on n from the y-axis. So at the moment, we can see that our period, which is how long it takes to go through one cycle, is 2 pi. If I make n 2, we can see that in 2 pi, we now go through 2 cycles. So the period now is now pi. It starts to repeat after pi radians. So we would say that's a dilation by a factor of 1/2 from the y-axis. So basically it squishes the graph. And yeah, and it's from the y-axis. So it's from the y-axis is this direction. So we're sort of squishing it in that direction. If we made n 0.5, you can see that would sort of stretch it out. So this would be a dilation by a factor of 1 divided by 1/2, which would be a dilation by a factor of 2 from the y-axis. So it'd make everything 2 times larger. All right, similarly, if n is negative, this actually corresponds to a reflection in the y-axis. And it's a bit tricky to see because I haven't drawn the other part of the graph over here, but take my word for it that this is a reflection in the y-axis. Okay, let's put n back to 1. All right, h. From all the other functions you've learned, hopefully you realize that this h value is what's going to shift it h units parallel to the x-axis. So it basically means it's going to move it right or left. If h is, let's say, +2, let's make it 2. You can sort of see that's shifting it to the right by 2. If it was -2, shifting everything to the left by 2. Now, because I'm just graphing it between 0 and 2 pi, it can be a bit hard to see that it's a shift. But just pick some point. Let's look at this point at the bottom here and just watch it move to the right as I move the graph. So hopefully you can see that's a translation left to right. Okay, and then the last thing is this k value, which is a vertical translation. So if I move that up and no, there was a bit of error with my the way I set it up, but hopefully, yeah, now we can see that if we change k, as if k is -2, it shifts the whole function down to -2. If we make it at +2, shifts the whole thing up to +2. Okay, so we would say that this k value is what is it called our mean line, or what I like to think of the line of oscillation, the point, the line around which the whole thing goes up and down below. So yeah, our mean line for this at the moment is y = 1 because that's our k value. And so, in terms of translation language, we would say that the k value is a translation of k units parallel to the y-axis. So hopefully you found that useful for the different properties of sine of x function.